Let's travel about 4,000 light-years away to the Messier 36 star cluster. Imagine you're looking at a perfect family portrait of stars. Looks pretty normal, right? Well, almost. Because hiding in plain sight is a cosmic photobomber, a real mystery that took scientists decades to figure out.
You know, M36 is what you might call a perfectly average star cluster. It's not super young, but it's not ancient either. It's kind of the middle-of-the-road, quiet neighborhood of the cosmos. And that's exactly why our photobomber is so fascinating. The real story here isn't about the crowd. It's about the one object that just doesn't seem to belong. Okay, so take a look at this infrared image with me. Among all those thousands of little points of light, one of them just stands out. See it? It's redder, it's fuzzier, and it even looks like it has a tail. This isn't just a star. It's more like a smudge, a ghost in the machine. That's our photobomber, and believe it or not, it was found completely by accident.
Astronomers were so captivated by this thing, this flowing gas, that they gave it a special name, Holoea, which is the Hawaiian word for that very thing. It was a beautiful name, and, as it turns out, a huge clue to the incredible puzzle they were about to solve. So what exactly is Holoea? Well, to figure that out, we need to talk about something called young stellar objects, or YSOs for short. Honestly, the best way to think of them is as stellar toddlers. They're not quite the stable, mature stars like our sun yet. Nope, they're chaotic, they're messy, and they're still figuring themselves out. These YSOs, these baby stars, go through a couple of key stages. First up, you have a Class 1 protostar. This little guy is basically a newborn, still wrapped up tight in its blanket of gas and dust. You can really only see it in infrared light. Then, as it gets a little older, it grows into a Class 2 object. It starts to shed that blanket and finally reveals itself to the universe, though it still has this dusty disk of material swirling around it. The very first explanation, which came out back in 1996, was just beautiful. It was so elegant. Scientists thought Holoea was a star they'd caught in that super rare, fleeting moment of undressing, transitioning from that hidden Class I phase to the more visible Class 2. It seemed to fit perfectly. But there's always a but in science, isn't there? There was a catch. See, young stars like this are supposed to have two jets of gas, a bipolar outflow, shooting out from their poles. Holoea only had one, so what gives? Where was the other one? Well, the initial theory was pretty straightforward. A really thick disk of dust was just blocking our view of the second jet. Problem solved. A neat, tidy explanation that seemed to wrap everything up. And, if the story ended right there, it would be a nice, simple tale of scientific deduction. But of course, it didn't. As the old saying in science goes, they foolishly decided to collect some more data. And that's when everything changed. So, armed with new, incredibly powerful sub-millimeter telescopes that can basically see right through all that dust and gas, astronomers took a much, much closer look at Holoea. And what they found? Oh boy. It completely shattered their simple, elegant theory. The old view was this single, fuzzy object with one jet sticking out. But the new, super high-resolution view revealed the truth. It wasn't one object at all. It was two. And we're not talking about two parts of the same star here. These were two completely separate objects, which they named SMM1 and SMM2. And get this, they're separated by a vast distance, about 7,300 times the distance from the Earth to the Sun. Our lone photobomber was actually a pair of twins. And they weren't identical twins either. SMM1 is kind of the bigger, younger sibling, about 1.5 times the mass of our Sun. SMM2 is a bit smaller and a little more mature. So what we have are two baby stars born at different times right next to each other in the same cosmic nursery. So, what about our original mystery of the missing jet? Well, the answer was stunning. The single jet was never a single jet at all. It was actually two completely separate outflows coming from two different stars that just happened to overlap from our point of view. SMM1 was powering a powerful east-west outflow, and SMM2 was powering its own separate northeast outflow. Absolutely wild. And this velocity map shows you the new reality in all its chaotic glory. The different colors represent gas moving at different speeds. It's a swirling, turbulent storm of creation. This is not a simple, neat outflow. It is a beautiful mess, the signature of a tiny, active stellar nursery. And that really brings us to the core lesson of Holoea's story, summed up perfectly by one astronomer. Star formation is a really messy process, and the more closely you look at it, the messier it gets. What we first mistook for a single, simple event was actually a complex, chaotic dance of multiple stars being born. So to sum it all up, the photobomber Holoea was never a single star. It was a tiny, hidden stellar nursery, home to at least 2 protostars, each with its own outflow. And that's what makes this story so powerful. It's a perfect example of how science works. A simple story gets messier, more complicated, and ultimately much closer to the truth, all because we get better data.
And that leaves us with a final, tantalizing thought. As our eyes on the universe get sharper and sharper, how many other simple objects out there are just waiting to reveal their own hidden, beautiful complexities? What other secrets are hiding in plain sight, just waiting for us to look a little closer?